Okay, perfect. Let me just raise my volume. There we go. Good evening, everyone. I will make a quick recording. Just be sure to have this sheet with you and this sheet with you as I go through the material. I will be sharing my screen. So let's go to screen 2 and go ahead and work on this. Okay. So I wanted to just quickly go over this, okay? I will be, again, taking pictures of this and sending it out, but I wanted to go over it first. You would want to remind yourself that I squared equals -1. This is a chapter 3 review. When we are working with i's and just, we are being asked to reduce them and simplify, make sure that you remember to write them in A plus BI form. The test might tell you to write it in A plus BI form. The test might not ask you. You have to know to write it that way, okay? It will be marked probably incorrect or partially correct. So please make sure that you do this. All right, in this example, for example, number 4, there is a negative outside the parentheses. You are not multiplying these 3 binomials. You are literally just distributing the negative and dropping the parentheses, okay? When you do that, you get all these different terms. Some of them have numbers, so constants. Others have the letter I. So the letter I is something that you leave alone. It is an imaginary number. You put the numbers together, basically the constants, and then you put the i's together. You put it in A plus B form. You reduce, you add together, you're done. This is a subtraction problem. The next one has 2 parentheses close to each other, actually next to each other, immediately next to each other, with no sign in the middle. So that means you're going to multiply. So in this case, it does require to FOIL, and it does require for you to know your rules of exponents. So you have to remember to add the powers if you have the same variable, like x to the 2, x to the 3, that is x to the 5, right? If you have i's, you treat them exactly like you would any variable, like the variable x. The only thing is that at the very end, you have to remember that any I squares need to be completely gone and turned into a -1. Oops, I should have brought this down. Once the I squareds become -1s, that will then make that piece, that term, a number, which will then add to the other numbers, and that will be in the constant side. And you always write your answers in A plus BI form. The plus is relative. The plus could be plus or minus, right? It's A and then the number I form. When you are dividing, and I already did this on a previous video, and you should have seen it from the media. You should have also seen it on the homework. Remember that when you are dividing, you make sure that you multiply by the conjugate. So the conjugate of -3i is +3i. And when you multiply, you would just multiply the top, multiply the bottom. You end up with I squares in the bottom, which gives you a constant, and the i's end up moving to the numerator. It is not to disappear the I will not disappear. It's just moving from the denominator to the numerator. Some, like for this, because the denominator is a monomial, which is one term, you technically don't have to multiply by 3i. You could just multiply by I, and that is enough to make the I squared disappear. However, when you are dealing with a binomial in the denominator, you do have to make that entire binomial a conjugate, which is just basically switching the sign in the middle between the constant and the I term. So you would change that sign, and then you would FOIL the denominator, FOIL the numerator. When you FOIL, like this student, because I had students do this, this specific student FOILed everything out. But the shortcut to multiplying conjugates together is the fact that the middle pieces will cancel. Okay, so this is numerator, denominator. In the second step, this is an equal sign. So equal signs look funny, right? These are equal signs. Okay. And here you have numerator, denominator, numerator, denominator. And so at the bottom, you will only end up with a single number, so a constant. And that constant will then make sure that you split. So notice there's a light, I believe that's pencil. Yeah, so you split them like this. It clearly says the word split to make them into the constant and then the I portion. Okay. All right. Okay. Okay, this is something that I briefly went over, and I'm not focusing too much on this. Okay. So this is just to kind of briefly go over this. I already went over this. This is just to plot imaginaries. Okay. This is the imaginary plane that we were talking about earlier, that one of the students asked. And here you know that the real is the x and the imaginary is a y. So all the numbers will be in a plus bi form. Each dot is a comma b. Okay. So that. All right, this one. So let me just cover up some stuff here. All right, going over this, this is the vertex form. So if you look at the vertex form sheet, which is actually that piece of paper that I'm using to cover this up, okay? The vertex is the opposite of this number inside, comma, keeping the second term the same. So this is a -4 with a +4. Therefore, the vertex of this specific parabola is -4 up 4. VT stands for vertex. That's what I wrote down because I couldn't fit it. So it's -4, 4. Okay. The parent function is dropping the A, the H, and the K. We've already talked about that. The movement is 4 left. So you take the opposite of that. That moves it left, right, left, 4. This number outside moves it up, down. It moves up because it's positive. This number is a stretch. It's going to stretch it. It's going to stretch it 3 times as long. Okay, so it's going to be skinnier than your parent graph. And then your vertex then is -4, 4. The axis of symmetry is x equals the x coordinate. Make sure that you include x equals that number. If you just put that number, that will be half the credit because -4 means nothing. It is literally a vertical line, which is what you see here. Vertical lines are x equals a number. This is a minimum because it is a happy phase. So even when you're happy, you're still down a couple times. You still could get sad every now and then. It is a happy phase because this is positive. And so therefore it's a minimum. And then you get the y coordinate of the vertex. So AOS, that's the x coordinate, minimum, the y coordinate. Okay. Domain and range for any happy or sad parabola is all reals, left and right forever. And the range is going to depend on that value of the y of the vertex. So if it's a happy, it's going to go from 4 all the way up to infinity, touching 4. Y equals greater than 4. But again, try to remember to do everything in interval notation. If it were a sad phase, then it would go from -infinity up to that point, because you always read them left, right, down, up. All right, so that is explaining what I have here on the paper, which again, I will send to you. This one is a standard equation of a parabola, and these take a little bit longer to find the information, specifically the vertex. Once you have the vertex, everything is pretty much straight from there. In this case, with the standard form, notice that I don't ask for vertical shift, or horizontal shift and stretching, because it is not in this format. So don't ask for horizontal shift, vertical shift, or stretch, because it's not in this format. So you will, again, get the same information, which is vertex, axis of symmetry, minimum, max, domain, and range. It's just going to be found a bit different. And for this, you need to do a little bit of math. Again, you have to look at that sheet that I am using to cover, but it's basically, you have it in this format. Make sure it's in this format, specifically in this order. Opposite of b over 2a gives you the x coordinate of the vertex. That's exactly what I did. I extracted my a, b, and c. I have it up here. I plugged it down here and I got it too. You could also plug that into the calculator, and you could find the vertex. However, if I require work, this is a work that you should show in order to receive the points, the full points. You obviously receive points for getting correct answers, but you don't get the full entire credit if you don't show your work. So you decide how many points you want to receive on every single question. All right, once you get your x coordinate of that vertex, in order to find its buddy, the y coordinate, then you have to plug this in back to this equation. Again, don't do this by hand. You have fancy calculators, so please make sure that you know what you're doing, okay? I did this obviously showing every part of the math, but you don't have to do this. Then you put these two together, it's 2 and it's -3. I am circling them because they are not final answers. I usually box my final answers. I put these now two together and that becomes the vertex. From here, you've got everything else. Make sure you have specific points. When you are applying these, don't just BS it. Make sure that you have specific points and you can get that from your calculator, right? You can just press 3 and it'll give you that dot. 1 and it'll give you that dot. So the vertex is 2, -3. Axis symmetry is x equals the x coordinate. The y is the minimum or the max, depending on whether it's happy or sad. In this case, it's happy face, so it's a minimum. Domain is always all reals. Negative infinity, positive infinity. Range depends on whether it's happy or sad, but this is a happy face, so it starts from -3, the y value, and it goes up to infinity. Okay, so I just wanted to go ahead and explain that as you look through this answer key. All right, the bottom says solve each equation by factoring. So when they ask you to solve, you need to set the quadratic functions equal to 0. If you are solving just a linear equation like 5x equals 2, you don't need to set it to 0. You just need to move variables on one side, numbers on the other. But if you are talking about a quadratic equations need to be set to 0. So we set this equal to 0. I don't like to work with negative x squared, so I divide by the whole thing by negative. Whatever you do, remember we were talking about that balancing of equations, so whatever you do to one side, you have to do it to the other to keep the balance of the equation. So I divide everything by negative. I then have 2 pieces. I do not have 3 pieces. So 2 terms is so much easier to solve for than 3 pieces, because 3 pieces, if you have your A term, your B term, and your C term, it means you have to do one of 2 things. Either factor, if you can. If it's not factorable, then you use quadratic function. In this case, when you've got only 2 pieces, it's easy because you just factor out what's common. So it's an x, and then you're left with an x plus 8. Then you set each of these pieces equal to 0, and you solve. You get x equals 0 and x equals -8. You have solved for the x-intercepts. So if you were to graph this function, let the 0 be equal to a y. If you graph the function on the right side, it's going to be a sad face because of this negative, and it's going to have 2 intercepts, 0 and -8. All right, the next one is also a quadratic. So just the fact that it is a quadratic, it means you're going to set it to 0. You're going to rearrange these in the correct order. See how they're incorrect? Okay, you have to put the square term, the variable, and then the constant. And then you factor. This student factored in factored using grouping. Okay, so if you want to know how to factor, if you need help with factoring, that's fine. You can just ask me, but basically you go from here to here. Okay, so these are just intermediate steps on how the specific person factored. And so you get 8 plus 1 and a minus 5. You solve each of them, you set them equal to 0, and you solve them, and you get your answers. So this function, if you were to graph it, is a happy face with x-intercepts at -1 and 5. Okay, and then you can stop the video, rewind, pause it, whatever you need to do to understand this a bit better. All right, here is another one. So I'm going to send this a copy of this. So I'm just going to briefly go over it. Set it to 0, factor, solve. Set it to 0, factor, solve. This one I didn't finish, but you got the idea. All right. When the book or the test or the exam or myself, I'm asking you to find the discriminant is the piece under the radical. So the piece under the radical in the quadratic formula, asks basically is going to tell you how many solutions you will have. It does not tell you what the solutions are. It just tells you how many. So just imagine if you have this piece under a radical, if you have a positive number, you're going to have two solutions because the quadratic function has a plus and a minus outside the radical. So that's why you have two solutions. If you have a 0 on the part of the quadratic formula, so the square root of 0, it doesn't matter whether it's plus 0 or minus 0, as we went over today. 0 is nor positive nor negative. So you will have just one solution. And if you have a negative under a radical, you're going to have imaginary. So that'll be two imaginary, 0 real solutions. And so you have to just make sure that you set it to 0. So you move everything to one side, just like I did in every single question. See that? I did that in every single question. I did them in all 4. I also put ABC, 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 so you could practice the skill and not mess it up. However, I didn't finish all the problems, so you could finish these. And then I found the discriminant by b squared minus 4ac. So I plugged in my a, my b, my c, wherever they belong, and I checked. If it's greater than 0, 2 real solutions. If it's less than 0, meaning negative, it's 2 imaginary solutions, no real. That is also found at the very bottom of this sheet. I'll just put it up there for you. So the discriminant equals 0, 1 real solution. If the discriminant is less than 0, no imaginary solution, no real solution, 2 imaginary. Again, if you want to, get the blank sheet and fill it out yourself, you're more than welcome to do so. Okay, if you want to just print mine, again, it's up there, then you're also welcome to do so. But I wanted to just get you started on some of these problems, leave some of them blank so you could finish them and know how to do this, okay? There should be no reason why you don't know how to do this because I'm showing you, I have them here. I'm allowing you to use this sheet and so on and so forth. So please study. These over here I already went over, so you can give them a try. Over here, I went over this. I'm not really focused on this one. These are kind of out of order. Should have gone C, D, and then C, D, and then this one. Actually, should have been I typed this up. So yeah, this one's a bit too complex. This one gets confused with this one. So anyway, as long as you know A, B, C, and then you know what the graphical representation of this means, a quick sketch, what it means, and all of that, then you're fine. This one we won't be having. It's a little bit tough, so I won't be having that one. However, I did want to go over, not the volume one, that I did not include it, not even on the homework, but I did want to go over this. So hitting a baseball is hit so that its height is feet, so many feet after t seconds, okay? And here's the equation. So your t is acting like your x, and the s of t, that's just a function. You can let it be the letter y if it bothers you so much. That's the y, and that represents the height. And that clearly says it here, height and seconds. So if you were to graph this, x is time. That's what this says here. That's your t, or your x variable. And height is over here on the y-axis. So if you want to know the height of the baseball after 1 second, you would plug in 1 in for t, which is replacing the time or your x value. Once you do all the math on the right, this is s of 1. Okay, so that will give you 32 feet. Whatever you get should be feet because you are looking for the height. You do not divide by 1. That's weird. The next one says find the maximum height of the baseball. So this is a sad parabola because it's got a negative, right? So it looks kind of something like this. Again, you can graph it. You can definitely find the vertex from the calculator and just mathematically prove it for purposes of the exam, showing your work to get the full points. Then you would just give me the work, right? In this case, because it is in standard form, then you use opposite of b over 2a, you do the math. This is your x, which actually is not your x, it's supposed to be your t. This is your t value, which acts as your x. It's the x coordinate, but in reality, you're solving for time. So the time is 1.375 seconds. When you plug that into the equation back in here, which is what I did, and I did this all on my calculator, did not do that by hand, you get a number. That number is feet. So at 1.375 seconds, it will reach its maximum height of 42.5 because that becomes the vertex. Now the next question is, to the nearest tenth, how long does it take the baseball to hit the ground? You go back to this equation. So for part C, you need to set the equation equal to 0 because the height, which represents this whole function, is 0. That's when it'll hit the ground. Okay, so this is A, this is B, this is C. My quadratic equation, instead of using the letter X, I have to use the letter T. Opposite of B plus or minus B squared minus 4AC. Square root of that all over 2a. And now I'm going to plug in. This is what I do. Opposite of b plus or minus square root b squared minus 4ac. That's literally what I do every single time. And I never mess up the sign. So I'm doing signs, formula, and everything at the same time. I'm bound to make mistakes. So grab a different color. My b's go here, and b is 44. Okay, then it's followed by A's down here. So that's negative 16. And the C is the last one that just goes in once. Okay, so I'm trying to find the time in which the baseball will hit the ground. It's going to hit the ground, right? Because you're shooting it up. So it's actually 2 times. It's here and here. But if we get any negative answers, we need to get rid of them. All right, so let's do the math. So T equals negative 44 plus or minus, let me do the math here, 44 squared. That is 1,936. Okay. Bottom should be 32 negative. These 2 negatives, in these 3 pieces, I've got only 2 negatives, so that's going to be a positive. And now I'm just going to, so first I take care of the sign, and I take care of the numbers, or first the numbers and the signs. I don't do everything together. That just creates more mistakes. So that is 16 times 16, that's 256. And I'm going to add that to 1936. Negative 44 plus or minus 2192 all over negative 32. Okay, so let's see if 2192 has a perfect square. Nope, it doesn't. But notice, and please always read the question. It says to the nearest tenth. So you will be rounding this. Okay, so I just took in my calculator the square root of that. And that was approximately 46.8. I'm going to give it more decimals because it's not the final answer. So the more decimals I have, the more exact the answer is. 18799 all over negative 32. So now you have to split this 2 ways. One of them, you're going to just, let's do this, write everything with a positive, and then the other one, you're going to write everything with a negative, okay? So 2 equations, negative 44 plus 46.818799 all over negative 32. The other one is negative 44 minus 46.818799 all over negative 32. Okay, so let's figure out the 2 answers. Now I'm going to do the approximation. So if I have, now before even doing the math, I notice that if I subtract these 2, I'm going to get a positive on the numerator, right? Because this, if I take $46 and some change and subtract 44, I'm going to get a positive number. I'm going to get positive, right? Now, if I divide a positive by a negative, that's going to give me a negative. So I'm not going to waste my time in doing the top one because I cannot have negative time. So I'm not going to even worry about that. The second one looks weird and it looks wrong, but it's not wrong. The top will give you a negative number with a negative 32. Those 2 negatives will cancel and that will actually give me a positive time. So this will be negative 90.818799. and I divide that by 32 because these are going to cancel. It's approximately 2 point, said to round up to the nearest 10, 2.86. Okay. You can copy that down. When I take pictures, I did not include the work. I just show the answer, but that's how you would do it. This is not factorable. Just by looking at those answers, these are not factorable. Okay. So that should give you a good idea of what should be and will be on chapter 3. Preparation for chapter 3 on the exam. Let me zoom out a bit. All right. Let's go on to unit 4. Unit 4 is a bit more difficult, most definitely. Okay. So I went over this, I went over this, I went over that, I went over that. Okay. Use the end behavior to describe this function. Okay. When you are working through these, you want to just make sure that you know the degree and its coefficient. The degree, if it's even or odd, the coefficient, if it's positive or negative. I've said this in the previous video. I'm just going to do a quick run. I'm not going to solve every problem. And then those two will tell you how the graph goes. If it's like opposite arrowheads, if it's odd, remember I said that today. If they're even, if they're the same way, right? And in which direction. So make sure you get that down and you know what to do there. This one is very similar to what we did today. So this one is asking how many real zeros does the function have? The fact that it says real, it means visually seeing how many times you see with your eyes, how many times it crosses the x-axis. Well, that would be 3. Okay. This one, which one would be a cubic? And so by what I explained today, and thank you, Kelly, for those questions, I can show you, you can actually do these now. Okay? The ones that we did in class were so much harder. Okay, this is again end behavior. Make sure that you know that all of these have arrowheads, right? And you already know these. You will have them on the exam and you have them on the homework period. All right, for this one, dividing, I don't know if I included some of these. I'm going to be sending out an email with all the information regarding the next exam. Just be patient with me. I'll do it right after this recording. But if this is on the homework, this is just something that you have already hopefully seen. When you have a binomial in the denominator, you basically just do this. You divide each piece by that. And you just cancel x's. That's literally what you do. And then you just reduce these. You literally divide. So it's 5x cubed minus, this is 2x squared. You're done. That is it. That's only if you have a binomial, sorry, a monomial, one term in the denominator. Then you can select, divide those pieces by that monomial and then reduce. When you have these polynomials divided by binomial, you have to do one of two things, either synthetic or long division. It is technically your choice until you have specific instructions that ask you to do it a certain way. In this case, it says synthetic. So with synthetic, you have to make sure that all of the terms are accounted for and that they are in a decreasing order. Okay. So I've got a power of 3, a 2, a 1, and no power. That would be a 0. They are in decreasing order. This is good to go. Now, what am I going to divide by? If I'm doing synthetic division, I have to set that equal to 0. Subtract the 1. So the number I'm going to be plugging in is a -1. Please check out the previous videos to check out how to synthetically divide. So I'm going to put I'm going to just grab the coefficients. 1, 5, 9, 5. The last number, I always draw a line because this is the remainder. I'm going to put a box here. Okay. This number goes in here. And you start by dropping the first term and then multiplying by the box. Let's put a box in. And then you write it down there. So -1 times 1, -1, and then you add 4. 4 times -1, -4, and then you add 5. 5 times -1, -5, 0. So watch the instructions, read the instructions. This says use synthetic division to divide the first polynomial by the second. When they ask you to divide, you are going to give another polynomial as an answer. Okay? We give you one, we give another. It's going to be much smaller and the powers are going to shrink. So if this is a cubic, this one's going to start at a squared. So if you start at a cubic, this is going to be 1 down, so it's going to start at a 2. If this were a 5th degree, then you'd start this one at a 4th degree. Every time you divide, if I had synthetically divided once more, then I reduce it by 1 more power. So you attach these coefficients next to their power. So that would be 1x squared plus 4x. And then the next one is constant. And that's how it should be. You should end up with all these numbers matching until the last one is the constant. Plus, if this were a remainder, you put the remainder over the divisor. In this case, this is 0. So when you have a remainder of 0, you can just write this. You don't need that second piece. Okay. Also know, this is further in chapter 4, when you end up with the remainder of 0, it meant that this is a factor of this big polynomial. It means that when you graph this polynomial, you will have a 0. Technically, this is y, this is 0, which means an x-intercept at -1. Okay, this all comes together when you see future problems. This and use this one. Okay. This one says use synthetic division to determine whether the given number is a 0. So that's exactly what I just said. You would take the coefficients, make sure these are all in descending order. You don't have any missing powers, just like this one. And you don't have to solve. They're giving you the number to plug in. So you plug in a -5, and if you end up with the 0 in the remainder, it means that this number is a 0, which means it's an x-intercept. If you do not end up with a remainder of 0, it means it was not a 0 of the function. Okay. The intermediate value theorem to show that there's a 0. So this is basically what the calculator does. If you plug in, let me just use this piece right here. If I have, this is a parabola, so you know it's a happy parabola. What they're asking, so more than anything, I'm just going to explain what they're asking so you understand. I'm just trying to do the problem. They're asking that by the intermediate value theorem to show that if there's a real 0 between the two numbers given. Real 0 means if it crosses the x-axis between 1 and 2. Okay. Whether it crosses this way or that way, it doesn't matter. We know it's a happy face. We don't know if this parabola is up here, so maybe it doesn't cross at all. We don't know if it crosses twice or it crosses once. We don't know. We just know it's a happy face. And that they're asking between 1 and 2. So how would I figure it out? If it crosses the x-axis, and let's say that you are asking your calculator, how do I find a 0 in the calculator? You go to second, calculate 0, and it'll ask you here on the left, bottom left, it'll say left bound. And then you have to press, right? Enter somewhere. So the cursor's moving. The cursor left of the 0 that you want to find. So this is left. And you press enter. When you press enter, it then asks you for right bound. So then you move your cursor right here, because that's right at that point. And then it asks you to guess. And the guess, you can just put enter again, right? And then if it crossed, it'll give you that exact dot, and it'll give you a number, comma 0, right? Now, every time you find a 0 of a function, doesn't matter if it's this way or if it's that way, you're going to notice that the y values are going to be opposite sign. This one is above the x-axis, which we discussed earlier. That's a positive. And this one has a negative y value. Anytime there is a change in the signs on the y values, that means that it crossed the x-axis. There's no way that there is a 0 that has 1 point above, 1 point below, and the two signs on the y values are the same. This is not possible, okay? So that's basically what it's asking. So the easy thing to do, and again, you would look at the lesson, you plug in a 1 into your function, literally substitution, because that plugging in of the x will spit out a y value. And then you plug in a 2, plug that in there, and that 2 will spit out a y value. So if your two values that you get from plugging in a 1 and a 2 are different signs, then it means that there is a real 0 between 1 and 2. If the signs are the same, no real 0. It means that the parabola either is flying up here. It doesn't mean that there's no 0 there. It could be where it crosses, but right at 1 and 2, there's no 0 because between 1 and 2, it's high up here. You could have a 0 to somewhere else. Okay, so you go ahead and do those. That's really easy. All right. The next one says use synthetic division to perform. Again, I'm not going to do these because these are fairly easy. You just have to know how to put them. You have to make sure that all of the pieces are accounted for. So what you want to do is rewrite this. X to the 5th. We don't have a 4th term, so you put a 0. You don't have a cubic. You don't have a, I always put pluses. When it's 0, I just put pluses. Minuses can get a bit tricky, even though 0 is not positive or negative, but you have to put a sign between them. There is no x, and then we've got the constant. Then you pull all the coefficients, and you synthetically divide by a positive one. Okay, because when you set this equal to 0, you end up with a positive one. Okay, so you would finish that. 15, divide the expression. This is long division. You don't do this by synthetic because the form is not x and then a number. Like the previous one I hear, you don't have x and then a number. This is 5x minus 4. So you would do long division. I don't know if I included one of these on the exam. I'll send out the list again of what I included and how many questions there are, but just study. This one says factor f of x into linear factors. Okay, so we're going to practice these synthetic division again, but I just want to show you what it is that they mean. I have a polynomial. So, it's in decreasing order. I'm not missing any powers. 4, 3, 2, 1. Constant k is 1. Okay, so factor f of x into linear factors given that k is a 0. Let's tell you that this is a 0. What does this mean? That I should end up with the remainder of 0. Okay, let's check it out. 4, 13, negative 32, 15. This number, the way it is exactly, you don't change the sign. You only change it if it is in a binomial form. Okay? They tell me that this is a 0. It means that at 1, it's going to cross the x-axis. And therefore, the remainder has to be 0. So I'm already going to put a 0 in here. If I do not get a 0 after all of this, I've made a mistake. I either messed these numbers up, I'm missing one of them, this one is incorrect, something happened. All right, let's check it out. Bring this down, 4. Multiply with the box, 4. Add 17. Multiply with the box, 17. Add, okay? And that'll be definitely a negative number, which should be 15. That when you multiply, you get a negative 15, and boom, that is a 0. Okay, what does this mean? It means it was a 0. But let's go back to the question. Factor f of x into linear factors. So they want this function written into linear factors. So 3 pieces multiplied together, that gives us this. This is not factorable, which is why you can't do it by hand. You need the help of this information they gave us. So I've got 1 factor. You need 3 because that's the highest power. That's the maximum number of x-intercepts. We went over that today. I need to find the other two. Whether they're imaginary or not, you have to find them all. Okay? So if I took this cubic and I divided by this and I wanted to write a polynomial function, this is now a degree of 2. So let's write this polynomial function. Because this is a squared, you can always factor or quadratic formula. One of two things. If this were a cubic, you'd have to find another number to synthetically divide by to reduce it down to a square. So you could factor this out if it's factorable. If not, you could use quadratic. So I actually don't know. Let's see. Let me do this in pencil because I need to erase later on if I make a mistake. Let's do 2x. So I'm doing the factors of 4, which go in here, with the factors of 15 that go here. And if I do have a face, that's the mouth. That's the nose. If I do outer and inner, I should get positive 17. So let's try 5 and 3. Factors of 15 are 1, 15, 3, and 5. I only have 2 pairs to choose from. Factors of 4 are 4, 1, 2, and 2. So I've chosen this one with that one. This is a negative. They're opposite signs. So I get 10x. This will give me 6x. But it's not 17. I don't know if it's factorable. If I swap these, it doesn't make a difference because these are the same. If I do 15 and 1, those numbers are way too big. 15 is way too big, so this won't work with that. Okay. So I'm going to leave the 3 and 5 where they are. And now I'm going to change these two. I'm going to choose this pair instead. 4 and 1. Same. That's negative 12x, and that's positive 3x. That is not 17. But what if I then swap these? The guess and check method, by the way. That's a 5. I don't think this is factorable. This is 12. Did I do that right? 17, 17, 18, 12. Yep. And if I do 15 and 1, the last one is to match this up with that one. That didn't work. So if I do 15 and 1, that's 15x negative, and that's 4x negative 11. If I put the 15, if I swap these two, this number is way too big. So I don't think it's factorable. I think we're going to end up doing quadratic formula. So let's just do quadratic formula, see what we end up with. Maybe it is factorable. I don't know. I don't want to be wasting my time. X equals opposite of b plus or minus b squared minus 4ac all over 2a. 17 plus or minus, some big numbers. 17 squared is 289. A negative times a negative is a positive. 16 times 15. 240. All of 8. Let me just double check. 240 plus 289. 529. I think that has a perfect square. Oh, did I do that right? This is an ugly number. Oh, it is. So it is factorable. Okay, so you would do 2. Negative 17 plus 23 over 8. Negative 17 minus 23 over 8. We've got 2 answers. Okay. Yeah, I think this was factorable. You can see that? Yes. Oh no. 23 minus 17 divided by 8. And again, don't do decimals, do fractions, just reduce. I'm going to cut that in half. 3, cut that in half, 3/4. The other one is adding these numbers, negative 4, 8, negative 5. So what's factorable? Okay, so that means one of them was plus 5. The other one was 4x minus 3. That's what it factors to. Yeah, I don't think I did that. I did this one with that one, but I didn't do this with that. You have to find the right combination. You have to pick one from here, one from here, such a way that when you do the happy face, you get 17. So I didn't write it. See, this is 20x minus 3x, that's 17. If you factor it, this is what it should factor to. If you do quadratic, it should be the same answer. So when you are asked to write it in terms of linear factors, you've got your factors, but they're not linear factors. Linear means they look kind of like mine. So your factors were k equals 1, k equals 3/4, or x, whatever you want to call them, doesn't matter. So your factors are going to be p of x, f of x, I'm sorry. They gave you f of x. You're going to write them in the form x minus the number. So x minus k form. This is the form. And there's 3 of those, so you should have 3. So it is x minus 1, x minus 3/4, x plus 5, because it's a double negative. This is now factors. And now you have answered the question completely. So if you just stop here, you've solved it, you have found the answers, but you have not given your answer in linear factors. There's an R. Linear factors. Okay. All right. The next one says, number 17, says find a cubic polynomial with real coefficients having the following zeros. So they tell you the answers. And now you have to find the polynomial. Okay. Now notice that it has a cubic. So if you need a cubic, you need at least three zeros, right? It is a maximum, yes, but when you are given zeros to come up with a polynomial, they have to give you all 3. The maximum number of real zeros is 3. It means that visually your eyes will see a maximum of 3. However, if there is only one x-intercept, so only 1 0, it means that the other 2 were imaginaries. There are a total of 3 in the complex world. In the real world, you might not see all 3. So if there's one imaginary, if there's one real, there's gotta be 2 imaginaries, okay? Could there be 2 reals? So 2 that you physically and visually see and 1 imaginary? No, because the imaginaries always come in pairs, okay? That's why when you are given a cubic, you can have 3 x-intercepts that you can visibly see, or you can have 1 or none, okay? But that's because of the rule where imaginaries come in pairs. So this one, they will give you an imaginary. You have to come up with its conjugate. And now you have 3. So you will do the same thing that we did here. The polynomial will have x minus 4, that's this one. X minus 3i, that's this one. X plus 3i. You do not leave your polynomials in forms of I. That's just the beginning. What you have to do is convert them, like multiply it all out, basically, and the i's will disappear. So I'm going to leave this alone. The first one you want to do is these, because these are conjugates, therefore some stuff will cancel. So if I FOIL, I get x squared plus 3xi, and then minus 3xi, and the last one is minus 9i squared. Notice that these cancel. So I have x squared plus 9i squared is -1. You should know that by now. So I get this. And now I can FOIL this up. No more i's. So that's x cubed minus 9x minus 4x squared plus 36. Now that looks horrible. You want to always put these in descending order. Cubic squared x constant. That is a polynomial that pertains to solutions having 4, 3i, and -3i. Basically what you do. We try the next one. Okay, the next one says, we already kind of did this already, but I'm going to run through the procedure. For the following polynomial, 2 zeros are given, find the remaining. How many do you have? Total 4. 4 in the complex world. There are 2 given to you, you find the remaining 2, whether they're complex or whether they're real, that's not the point. You have to have a total of 4. Okay. So you would go ahead and do that. You would synthetically divide twice. Okay. If they're telling you that they're zeros, you would get the entire polynomial, right? Make sure you fill in the zeros. So let me get started. So in this case, you've got p of x equals x to the 4th plus 0x cubed. See, there's no cubed in the equation. Plus 27x squared plus 0x. There is no x. And then there's a number. Okay, now you can extract these coefficients. And they give you the actual number. So you don't have to change the signs. You can only change the signs if you are given these in binomial form. So they give you a 3 and a -3. Okay, let's try the 3. And if they tell you that this is a 0, they're zeros, it means that this has to be a 0. If I don't end up with the 0, I've made a mistake. Some students forget these, and then they just do 1, the 27, and this one, and they don't get a 0. That means you were missing some placeholders. So bring this down. 3. Sorry. I said bring it down. I'm already getting ahead of myself. I'm sorry. 1. Multiply. Right here. Add 3. Multiply. That's 9. Add 36. Multiply. The big number. I'm going to add. So that's a 3, 8, 1, 3, 108. 108. And when you multiply, you should get positive 324. Okay. All right. Now, they tell you, if I were to write this as a polynomial, this doesn't count. If I were to write this as a polynomial to see if I could factor, this would be a cubic. I cannot factor cubics. There is no quadratic formula. There's nothing. I'd have to just, I'd be guessing, right? So the reason why they gave you 2 zeros is so that you can, I use this 3, is so that you can use the other number to synthetically divide again and bring that cubic, because right now this is at a cubic, down to a square. Okay? So I'm going to take this again. All right, I'm paper. I'll continue it here. Using some degrees here. Patience. Okay, so I'm going to take this again. 1, 3, 36, 108. I don't need this 0. And then in the box, I'm going to write the other number. This means that this also has to be a 0. So I used a 3. And I'm going to use a -3. Do the same thing. Bring it down. Multiply. Add. That's a 0. Multiply. 0. Add. 36. Multiply. -108. Boom. 0. So now this is a quadratic. So degree of 2. Over here, I had this as a degree of 3. So that's like the highest power, right? So now I'm going to write a polynomial, starting with a 2. 1x squared plus 0x plus the constant equals 0. And then I'm going to solve for the remaining 2. This, you don't need to write it down. That's just a 0. I have this. Those are easy to solve. You basically subtract it. And you take the square root. You've done these before. We have gone over these before. There's a negative in there, so you take it out as an I. Square root of 36, but don't forget your plus minus, because remember, you have to end up with, this is one. You have to end up with 2 more answers because you were given 2, and the highest power is 4, so there's a total of 4 minus 2 is 2. So that's plus or minus 6i. They were imaginary. So when you see this graph, if you were to plug that equation into the graphing calculator, you would only see 2 visible zeros. The other 2 are in the imaginary, but there's a total of 4. Between the complex ones and the real ones, there's a total of 4. Okay. It's 19. So this one, okay, you can make a rough sketch. You can graph either on your graphing calculator, and then you would find everything, right? And this kind of puts everything together. Chapter 1 all the way through now, how to solve, domain, range, extrema. The extrema means absolute max, absolute min, local max. So go ahead and find that. Increase, decrease, we went over that in, I believe, chapter 2. Any constant intervals, any zeros, so any x-intercepts, and the end behavior. And behavior are just the last 2 arrows. This is a cubic, so they're going to be facing different sides. Okay, this one we just solved one, like literally I just did that right now with -36. So you should be able to know how to solve that one right here. Okay, cubics or anything, anytime they ask you to solve, they'll be ready with either a quadratic. If it's anything bigger than a 2, then you'll be able to factor out the common. So this will, you would factor out an x, and then what you're left with inside is a quadratic, which then you can solve by the forms, by the ways that you already know. So factoring, quadratic forms. Okay, this one I'm gonna briefly go over. And then this is what I went over today. Okay, this is where you set the problem, and I gave it to you in 2 forms, so whatever is useful to you. Actually, this second one is the most useful because this is already in factored form, and this is a power of 4. You could not have factored it yourself. So do you use the second one? Right? To set each piece equal to 0. You solve, so you will get 3 answers because there's 3 different parentheses. And then you use those 3 answers to tell me what parts are above the 0, what parts are below the 0. These are polynomials, so it's not just going to be a parabola. It might have a lot of ups and downs. All the pieces that are above go here. All the pieces that are below go here. A cubic, it looks difficult, but all you do is factor out a y. You end up with a quadratic, which then you can either factor or use quadratic. These are all factored right away. All right, last one I want to briefly go over because I don't want to take too much time already. For this one, you have to look what is the possible list of rational zeros. So the possible list of rational zeros are the factors of p over q, the coefficients. So this is a 20, you find all the factors of 20. And then you find all the factors of 1 because the coefficient is 1. So this one's easy. So all the factors of 20 are possible rational zeros, are possible numbers where your graph crosses the x-axis. Now, you write the list here. So look at the media, we'll come into these videos. You would write that down. Then it says, use the graph to eliminate some of the possible zeros. So then you plug that graph into your calculator. And you're like, it looks like 4 is a 0 because it crosses at a 4 and you check. You press 4, enter, and it gives you 4, 0. You're like, oh, that is a 0. So you need 3 total answers. By the end of this problem, you need to give me 3 total answers, what the 3 factors are. Once you find 1, you do synthetic division, you will end up with a squared. Squares, I know you can factor. If this were a 4, then you'd have to find 2 zeros from the graph so that you can reduce it to a squared and do the rest of the work algebraically. You don't pull the answers, all of them, straight from the calculator, plus the calculator is limited because it doesn't give you the imaginary. So you would check which one is an actual 0 from your graphing calculator, plug that, synthetically divide by this. You should end up with a 0 as a remainder. And then that polynomial will be a quadratic, a squared one, and then you solve. And those will give you the remaining factors. Okay, that's what you do. So this is finding the actual real zeros, and then you write it in factor form. So it's basically putting, it's kind of like 16, where they give you 1 0, and then this now reduces it down to a squared. You then factor, you find the other 2, and then you write it in linear factors, which is this. It's basically like number 16. All right. So 23 is like 16. The only difference is you had to get a list going because they weren't giving you any zeros at all. The difference with 16 and 23 is at 16, they gave you at least 1 0. So you were able to start somewhere, right? See how this is also a cubic? See, you were able to do all this, do that, and get to the final answer. Here, you're not given anything. So that's why you do a possible list. You pick one from the graph that you see as a 0, and then you synthetically divide, and you do it just like 16. Just like 16, okay? So 23 has everything together with one extra step. Okay, that is the end of the video. I will be sending out the list of the questions that will be on the exam so you can start studying to hopefully get ahead and be more prepared this time. Okay, so I'm going to be stopping the recording. Thank you so much, everyone. Have a great night, and I'll see you next Tuesday.